So the simplified Diamond Like is basically a smart contract wallet that allows callback. And a callback in our case is basically a flash loan callback. That's why you would use it, at least in our use case. But the reason why this exists is because other solutions had either a storage at the high level, such as storage on slot 0, slot 1, etc. So there was a risk of overriding storage when doing a delegate call, and then the lack kind of a customizability. And so this is not a Diamond proxy. It simply uses inspiration from the Diamond standard to kind of take what we believe were kind of the best pieces of it while keeping the code as simple as possible. So why do we call it Diamond-like? Well, we have the Diamond-like storage, which is offset at this position right here. And so we basically offset all of our storage down there so that it's a lot harder to accidentally clash against that. And the reason why we did this was so that we could allow fallback handlers, which I'm gonna get to in a moment. But in terms of what the smart contract wallet is, you really just have this operation type that allows to specify a call or a delegate call. Then you're gonna have an operation struct with a to, whether we wanna check success, whether we wanna pass some if, the gas, whether we wanna cap the gas or we don't wanna, we just wanna pass all the gas left. And then an operation type, again, call or delegate call. And lastly, the data, the call data to perform the call, which will simply ABI encode off chain to perform this. And so at its core, again, this is just a good old smart contract wallet with some extra things. So let's look at the basics here. We got the execute and we got execute one. So execute will simply receive more operations and then perform them in a sequence. And we, for safety, we basically have this check at the end where we always reset the callback enabled back to false. We don't even check whether it was changed. We always do it just to be safe by default because the 100 extra gas doesn't really make that big of a difference to us. And then in terms of executing, we basically perform this as a low level call where we pass all of these values that we shown before. We show them above. And then at the end, if we want to check for success, we will. Otherwise, we're not going to check. So, I mean, we could argue about having stricter checks. However, those stricter checks could actually be enforced by delegate calling, or they could be enforced by performing further checks on contracts that would actually revert if the check doesn't pass. So while there is an argument to checking the call data, that's such a broader surface area that we didn't do it. And so at this point, we kind of explained how the wallet works. What you'll see down here is that we actually have a fallback, and the fallback, if you look at kind of the logic down here, this is the same logic as the classic upgradable proxies, where we basically just call a implementation, right? This, you normally will see it as this, and we just delegate call to it. And the way we do this is by allowing what you would call facets on the Diamond standard, and what we just call, in our case, we just call callback handler, because that's what the purpose of the contract is. And so if a callback handler exists for that specific signature, then we're gonna allow to perform the call. And then we have this extra set of security checks here, where if you don't want to allow a callback, which by default it's this is set to false, so it means that by default you cannot receive a callback, and so the end user has to manually untoggle this, or they have to manually untoggle the callback enabled for one call, which, as I showed above, is resetted back. But basically, again, this is just a way to avoid allowing this functionality by default, but also we do allow it. And in terms of how you will change the callback handler, you will basically call these hard-coded functions here. Because they're hard-coded, they are going to have precedence over the fallback, which means that obviously you cannot have a fallback for those function signatures as they are already determined. And so we also have this check to prevent setting the new signature to execute, because obviously we don't want to allow that. And then in terms of changing the storage, we have this Diamond-like pattern where we need to grab the storage, the pointer to it, and then we can use the offset. So in conclusion, in terms of allowing any call, we will basically just set it here, And that should be kind of it in terms of the Diamond Like.